Welcome to our channel, where we demystify complex tech topics and bring you cutting-edge solutions for software development. Today, we're diving into a challenge familiar to many of you: optimizing Docker files for Java microservices. If you've ever wrestled with bloated images, slow build times, or security vulnerabilities in your Docker containers, you know the pain. But what if there was a smarter, more automated way? What if artificial intelligence could become your co-pilot, guiding you to the most efficient and secure Docker configurations? Manual Docker file creation, while fundamental, often introduces a host of inefficiencies. Developers, under tight deadlines, might reuse generic Docker files, leading to larger-than-necessary images. These bloated images consume more storage, increase deployment times, and can even expose a wider attack surface. Then there's the constant struggle with build speed. Every small change can trigger a full rebuild if your Docker file isn't structured to leverage caching effectively. And let's not forget security, often an afterthought, leading to containers running as root or pulling insecure base images. The cumulative effect? Slower development cycles, higher infrastructure costs, and increased operational risks. It's a critical bottleneck in the journey from code commit to production deployment. This is where the power of generative AI steps in. Imagine an intelligent system that can analyze your Java microservice project, its dependencies, framework, and build tools, and then automatically recommend or even generate a highly optimized Docker file. This isn't just about syntax correction. It's about applying deep knowledge of Docker best practices, Java ecosystem nuances, and security principles. AI can propose multi-stage builds to dramatically shrink image size, suggest optimal layer caching strategies for lightning-fast rebuilds, and enforce security policies like running as a non-root user. It transforms Docker file creation from a manual, error-prone task into an intelligent, automated process, accelerating your deployment pipeline significantly. To demonstrate this revolutionary approach, we've put together a conceptual project called AI OptiDoc Java. This isn't just theory, it's a hands-on demonstration of how Gen AI tools can recommend optimized Docker files for Java microservices, complete with sample Docker and pipeline code. The core components of our demo include a standard Java Spring Boot microservice, a Python script that simulates a Gen AI tool for Docker file recommendation, the optimized Docker file that the AI generates, a local build script to show the process, and a GitLab CI/CD pipeline configuration illustrating seamless integration into your automated workflows. It's a complete journey from source code to an optimized, deployable container image, all guided by AI. Our sample microservice is a simple Spring Boot application, a straightforward, Hello World, REST API built with Maven. It's representative of countless microservices running in production today. We deliberately kept it simple so that our focus remains on the Dockerization aspect, rather than complex application logic. The application exposes a single /API/hello endpoint, returning a greeting message. This simplicity allows us to clearly illustrate how the AI analyzes a typical Java project structure and its pom.xml dependencies, identifying the necessary build environment and runtime requirements. It serves as the perfect canvas for showcasing how intelligent Docker file generation can significantly impact even the simplest of services, setting the stage for more complex real-world scenarios. The real magic happens with our recommend_dockerfile.py script. While it's a simulation for this demonstration, it perfectly illustrates the logic a real Gen AI tool would employ. This script analyzes the Java project's characteristics, inferring the Java version, Spring Boot framework usage, and Maven as the build tool. Based on this analysis, it then applies predefined, intelligent rules to construct an optimized Docker file. Think of it like an expert system that knows all the best practices, multi-stage builds to separate build artifacts from the final runtime image, intelligent layer caching by copying pom.xml first, and crucial security enhancements like using a non-root user. It's the brain behind the automation, turning raw project data into deployment efficiency. Now, let's examine the output of our simulated AI, the Dockerfile.recommended file. This isn't just any Docker file, it's a meticulously crafted artifact designed for peak performance and security. Key optimizations include, firstly, a multi-stage build, which drastically reduces the final image size by separating the JDK build environment from the lean JRE runtime. Secondly, intelligent layer caching is implemented by copying the pom.xml file before the source code, allowing Maven dependencies to be cached and speeding up subsequent builds. Thirdly, a non-root user is established, Spring user, significantly enhancing container security. Lastly, critical JVM tuning parameters like XMS, XMX, and use container support are set, ensuring optimal resource utilization and graceful error handling within containerized environments. This is the blueprint for efficient, secure Java deployments. To see this in action, we've provided a build.sh script for local execution. This script orchestrates the entire process. First, it uses Maven to build our Java microservice into a fat JR. Next, it invokes our recommend_dockerfile.py script, which dynamically generates or updates the Dockerfile.recommended file with all the AI-driven optimizations. Finally, it uses Docker to build the image, referencing this newly optimized Docker file. The power of this local flow is that you can immediately experience the impact of the AI's recommendations, from faster builds due to intelligent layer caching to the creation of a smaller, more secure image. You can then run the Docker container and test the /API/hello endpoint, witnessing the accelerated deployment firsthand. While local execution is great for testing, the true power of AI-driven Dockerization shines brightest within a continuous integration/continuous deployment, CI/CD, pipeline. Our GitLab CI.yml example showcases this seamless integration. After the Java application is built, a dedicated CI stage executes the recommend_dockerfile.py script. This ensures that every build, for every code change, benefits from the AI's latest optimizations. The generated Dockerfile.recommended is then passed as an artifact to the Docker build stage, where the image is created and pushed to a container registry. This automated flow guarantees consistency, applies best practices without manual intervention, and significantly speeds up your time to market. It's automation not just for repetitive tasks, but for intelligent, evolving optimization. The benefits of adopting AI-driven Dockerization extend far beyond just this demo. Firstly, it ensures optimization and consistency. Every microservice, regardless of the developer, adheres to the same high standards for image size, build speed, and runtime efficiency. Secondly, it provides speed and reduced manual effort, eliminating the painstaking, error-prone process of handcrafting Docker files. Thirdly, enhanced security becomes a built-in feature, as AI can integrate security best practices and even scan for vulnerabilities. Finally, it offers adaptability and future-proofing. As Docker best practices evolve or new Java versions emerge, the AI can be updated to incorporate these changes automatically, ensuring your deployments remain cutting-edge without constant manual refactoring. It's about building smarter, not just faster. Looking ahead, the potential of AI-driven Dockerization is immense. Imagine systems that not only recommend Docker files but also dynamically adjust them based on real-time production telemetry, optimizing for CPU, memory, or network usage. Or AI that integrates directly with vulnerability scanners, automatically suggesting patches or more secure base images. This approach lays the groundwork for truly self-optimizing CI/CD pipelines, where deployment strategies evolve with your application and infrastructure needs. It frees up developers to focus on core business logic, confident that their microservices are packaged and deployed in the most efficient, secure, and robust